The next topic that we want to look at in this section is graphing the logarithmic functions. Before we graph logarithmic functions, I want to recall the exponential functions that we graphed before. The reason is because the logarithmic equation of functions and exponential functions are inverse of each other, which means their order pairs x, y will flip around. Okay? And also the asymptotes will be changing. So in exponential functions, let's f of x equal to 2 to the x power. We basically plot the points to get the shape of the graph from here, right? And notice that we have the horizontal asymptote in an exponential. And when we talk about logarithmic, because of their inverse of each other, this exponential, this horizontal asymptote become a vertical asymptote. And domain and range of the logarithmic function will also flip around in here. See, the range of the exponential function become the domain of the logarithmic functions. And then domain of the exponential functions become the range of the logarithmic functions. So to get this pattern graph correctly, so first thing that we do is we try to rewrite this into exponential form. So that means 2 to the y power is equal to the argument x. And what we do is we use this exponential equations to plot the points in. So instead of we plug it into for x, now we're going to have to plug in for y. So that means I'm going to be choosing -2, -1, 0, 1, 2, those 5 points for y. And that will help me to get my x value, which is when I plug in my y, -2, -2 to the 2 power, that becomes -1/4. And then this will be 1/2, this will be 1, and then 2, and then 4. Right? Basically, because what I'm plugging in for y with -2, that will become 1/2 to the second power, which is 1/4 is my x value. So notice that your domain and the x value and y value flip around. So in this case, what we're gonna have is we're gonna get a point at 1 will become 0. At 1 will become 0. And at 2 will be 1. At 4 will be 2. And notice that when you say half, it will be 0.5. Right? When x is half, it will be -1. When x is a quarter, which is 0.25, that will become what? My y will be -2. So as before, on the right side, this is going to be continue extending it. And on the left hand side, it will be continue going down, but it never passes through this y-axis. So therefore, we will have a vertical asymptote in this case. So we will have a vertical asymptotes. So this will become my vertical asymptote. Which is x is equal to 0. So I want you to have your 10.2 notes next to you so that you can see what's changing it on the first example of the graph. So in 10.2, when we graph the exponential graph, we have a horizontal asymptote. Now it becomes a vertical asymptote. And then look at the domain and range of this logarithmic equation. So my domain is basically start from 0 to positive infinity. As you can see, the x will be only, see, you don't have the graph on the left side of 0. So, and also it will never what touch it, that vertical asymptote. 0 is not included. And then my range will be extending down. The graph can be extended as far as down you want and as far as up you want. So it will be negative infinity to positive infinity. So from here, what we want to put a notes for the later on purpose is this. How do we find domain of a logarithmic functions? If you have a logarithmic functions, f of x is equal to log of base a, and with the argument, and your argument, my domain of this logarithmic functions, the argument must be greater than 0, meaning this value right here must be positive. Now you can use your calculator and try this. Okay, if you put an argument as a negative number, it will give you an error. Okay, so this is something that you need to remember to find out how to find out the domain of this logarithmic functions. Okay, so this is important. Okay, so let's try to graph the next function. So remember, these are parents graph. Later on, we're going to use these parents graph to do the transformation. So first, I'm going to rewrite this into exponential form, which is 3 to the y power is equal to x. So now I'm going to plug in the points. I'm going to find the table of values, x and y. And then like before, in order to get my x value, I'm going to choose my y value, -2, -1, 0, 1, 2, these 5 points again. So when I plug it in, that will become 3 to the -2 power. That is 1 over 3 squared, which is equal to 1 over 9. And this is my x value, 1 over 9. And similarly, if you continue computing, that will be 1/3. 1 0 power will be 1. 1 x y 3 to the 1 power is 3. And 3 to the second power is 9. So this will allow me to graph at 0. When x is 1, it will be 0. When x is 3, it will be 1. And when x is 9, it will become 2. So you notice that the graph, go flatter a lot faster. And then on the going to the left side of 1, if it is 1/3, it will be -1. And 1/9, it will be -2, which is like getting closer a lot faster, but never pass through. So this will be the graph of the Q function. So we still have the vertical asymptotes right here, the vertical asymptotes. Right? Vertical asymptotes, which is what? It's a vertical line, so it will be x equal to 0. So like, you notice that the vertical asymptote will only shift left and right because it will never shift up and down. So you need to pay attention on how the graph shifts left and right so that you will go along, you will shift your vertical asymptote later on also. So next is domain. So you can see that domain in this case is 0 to positive infinity, and the range, since you are talking about all the y values, so it can go extended to as far as down and as far as up, so negative infinity to positive infinity. So this is the parents graph of the log of base 3 functions. Since we graphed 2 of them already, I want you to notice certain things. Notice at this point, when x is 1, x is 1, y is 0, when the x value is the same as your base 2, then y value is 1, and that is never changing. Take a look at it. When x is 1, my y is 0. When the x is the same as the base, then it will be what? My y will be 1. So we can sort of use these 2 points and then remembering the shape of the graph to graph any parent's graph quickly and then use them to do the transformations later on. That's the idea that you need to get. Okay, so let's take a look at on the next example. which is natural exponential, natural logarithm graph. So this is basically talking about y equal to log of base e x. So when I write it to exponential, that will be e to the y power is equal to x, this situation. So what we want to do is we want to plug in the points like before, x and y, right? Plug in the points. For y will be -2, -1, 0, 1, 2. But this time you need to use a calculator to do the computations, right? So what you're going to do is you're going to plug it in e to the -2 power. That will be approximately give you what is your x value is. So e to the -2 power, that gives me approximately 0.135 dot dot dot. So we would just say that 0.14, right? So that we can count it easier. So next, I'm gonna try to change it into -1, and then that will give me approximately 0.37. And then when e to the 0 power, that will be 1, and e to the 1 power, that will be 2.71, and e to the 2 power, that's why we want to look at it, right? Then this will become 7.39. So now I can basically use these to graph it. So notice that decimal number is much harder to graph. So if you remember those like two cases that I talk about, x1 will be always 0, and then the same when the value of x is same as the base, which is approximately 2.71, that will be equal to 1. So now what we're going to do is we're going to graph this. At 1 will be 0 right here, and at 2.7 will be 1, and then at 7.3 or 7.4, that will be 2. Okay. And then if you go to the left, that will be, notice that 0.3 will be -1, which is a lot faster. So now with this, I can sort of like, get the same shape, and knowing that it never go through, pass through the vertical asymptotes. So here's my vertical asymptotes. So in this case, my vertical asymptote is x equal to 0. And my domain and range is still the same because we haven't do any transformation yet, shifting, right? So my domain will be from 0 to positive infinity. My range will be from negative infinity to positive infinity. Now, next example. When the base is fraction, it's going to be like before, it's going to flip around. In exponential, we saw that it flip around, so it will be flip around also. So like before, 1/2 to the y power, that is equal to x. And then we're going to plug it in the y values to find out our points. So -2, -1, 0, 1, 2. Computing this, that will become my x is equal to 1/2 to the -2 power, which is changing into positive exponent will be reciprocating the base, which is 2 over 1 is become positive 2. That will become 4. So I got 4 right here, 2, 1/2, and then 1/4. If you continue computing like this, or plug it into calculator, either one is fine. So continue this. At 1 will be 0. That point never change. At 1/2 will be 1. And 1 is 2, it will be -1. And then 1 is 4, it will be -2. Notice that the graph, like, flip around. So 1/4 will be 4 up here. So you can see that your graph is what? Flip around, but the same shape. And my vertical asymptote doesn't change. Still have a vertical asymptote at x equal to 0, right? And I already mentioned that the vertical asymptote only going to shift when the graph shifts left or right. My domain in this case is going to be from 0 to positive infinity again. My range in this case will be negative infinity to positive infinity. So now The next example, what we're going to do is use these parents graph to do the transformations. The key is I'm going to use these 2 points, the one that I highlighted earlier, to get my shape of the parents graph quickly and then do the transformation. So in here, my parents graph will be y equal to log of base 4 x. There's nothing add or subtract to it. And from here, I'm going to be doing transformation, which is log of base 4 x plus 3. So notice that I'm adding to 3 to x value. So that means what is going to be shift left 3 units. So to graph this, first I'm going to have to plot in my parents graph quickly, right? So remember, for parents graph, the 2 point that we're going to use is when x is 1, my y will be always 0. When x is the same thing as my base, then y will be 1. Right? And those 2 points will help me to get the graph a lot faster, the parents graph a lot faster. So here's my parents graph. When x is 1, my y will be 0. When x is 4, my y will be 1. So according to the parents graph, I know that the shape is look like this. Never pass through. Now, because of the graph is going to be shifted to the left 3 units, my vertical asymptotes, which is right here on a parents graph, will shift it to the left 3 unit also. 1, 2, 3 right here. So always draw your vertical asymptote first. So that way you will know you have a bounded. You cannot pass through right here. So my vertical asymptote this time, that is x equal to -3. Now I'm going to shift those 2 points so that I can get the sketch of the graph. So this point, if you shift it to the left 3 unit, it will be 1, 2, 3 right here. This point, if I shift it to the left 3 units, let me erase these first. If I shift it to the left 3 units, that will be 1, 2, 3, which is right here. Now, with these 2 points, and then with the shape of the parents graph that we already know, I can basically do the sketching. And notice that you will never pass through your vertical asymptotes. So the graph will be bounded right there, and then this graph will be continuing going like this. So we got the graph that we want. So this is my parents graph. Quickly, drawing with 2 points that we observed it, always true. And this is my final graph, the red one. So let's try another one. So this time, the original parents graph should be y is equal to log of base 2 x. So nothing add, subtract to it. And the next thing that I see is what this negative sign, which is going to be reflect about the x-axis, because I'm multiplying the whole y value, right? The whole y value by negative, because log of base 2x is representing what? Your y value. So, right? So now my y is equal to, the next transformation is negative log of base 2x. That means your parents graph going to be reflect about x-axis. And then finally it will become negative log of base 2x, and then what? -4. So once again, your y value got subtracted by 4, so it means what? All your y value is going to be shifted less 4 units, so it'll be shift down, right? It'll be shift down 4 units. So now, to get my parents graph, I'm going to use those two, points, which is log of base x and y. When x is 0, my y will be 1. When x is the same thing as my base, my y will no, I'm sorry, the other way around. When x is 1, my y will be 0. When x is the same as the base, then my y will become 1. Okay, so you graphing the parents graph, which will be x is 0, x is 1, y is 0. When x is 2, y will be 1. And using these 2 points, I can basically sketch the graph. That's my parents graph. Now what we're going to do is we're going to do the transformations. First, reflect about the x-axis and then shift down 4 units. Since this graph is shifting up and down only, not left and right, so therefore the vertical asymptotes, it doesn't change. My vertical asymptote will be still at x equal to 0 in this case. Right? It's not shifting left and right, so therefore it will be just stay the same. Now let's do the transformation. Let's talk about this point. When you reflect about the x-axis, this point doesn't move anywhere. After that, when you shift down 4 unit, that's where this point is going to go down 4 unit. 1, 2, 3, 4, which ended up right here. Next, this point. When you reflect this point about the x-axis, that means this point will be going down right here. And then from there, I'm going to shift down 4 units, so it'll be 1, 2, 3, 4 unit, which is right there. And notice that the whole graph going to be flipped around. So my final graph, right, after the transformation, my final graph is going to look like this. So since the graph is flipped about the x-axis right here, so the graph will look like this. I cannot draw very neatly. That's a problem. So this is how the graph going to look like. All right. So that concludes the graphing part. In the next example, next video, you're going to see the logarithm equations.